In this question, we're asked to balance a combustion reaction where we have this hydrocarbon plus oxygen gives us the products carbon dioxide and water. So the hydrocarbon here is written in a little bit of a silly way. So I would going to go ahead and suggest we rewrite this. This is actually butane, but we can rewrite it a little bit differently so it'll be a little easier to see what's going on. So here we have one carbon plus two more, because we have two CH2s, plus another carbon. So we have 1 plus 2, which is 3, plus 1 more, which is 4. So what we ultimately have is C4. Then we have 3 hydrogens here, plus 2 times 2, or 4 more here, plus 3 here. So we have 3 plus 4 plus 3, which is 10 total hydrogens. So the total number of carbons and hydrogens we have are C4H10 gas plus O2 gas yields CO2 gas plus H2O gas. So now I've just rewritten it so it's a little bit easier to tell what's going on in C4H10 as opposed to this. So when you're balancing a combustion reaction, it's always a good idea to balance oxygen last. I always recommend you balance carbon, then hydrogen, then oxygen, but the most important thing is that you balance your oxygen last because it's in both products, so it's the most difficult to balance, which is why you do it last. So what do I want to do here? I have C4. All of my carbon in a combustion reaction goes into carbon dioxide. So when we burn hydrocarbons, like in gasoline, all the carbon goes into carbon dioxide. So if we have C4 here, we must have 4 CO2s. Remember that balancing is a guess and check method, so this may not be right. However, it's my first best guess. Here I have H10. So when I have H10, all of my hydrogen goes into water in a combustion reaction. So if I have 10 H's over here, I must have 5 waters because each water contains 2 hydrogens. And again, this is just my first best guess. Now I want to count the total number of oxygens on my product side and see if I can get the appropriate number of oxygens on the reactant side. So here I have 4 CO2s. Each CO2 contains 2 oxygens, so I have 8 oxygens from CO2 plus each 5 waters. Each water contains 1 oxygen plus 5 O's from the water. This gives me a total of 13 oxygens. What you'll notice is, if I have 13 oxygens over here, I can't get a whole number of O2s, because this is an odd number, so I need an even number. So remember, balancing is a guess and check methodology. The best thing that I can do here is double everything. So if I put a 2 here, so I have 2 C4H10s, I'm then going to have to double both of these. So instead of 4, I'm going to put 8. Instead of 5, I'm going to put 10. And that means that I'm going to need 13 O2s because I also want to double the number of oxygens. So instead of 13 O's, I need 13 O2s. But let's check and make sure that that's correct. So I'm going to go ahead and cross this out since we crossed out these stoichiometric coefficients. So now I have 16, 8 times 2 O's here, plus 10 more, because each water contains 1, which gives me a total of 26 O's. 16 plus 10 gives me 26, which means I need 13 O2s. Notice that this is a guess and check methodology. I did not start over when I found out that I needed 13 oxygens and I had O2. I simply changed to double everything to make it so I needed an even number of oxygens.